Hello, welcome back to Ali Khan Maths. Today I'm going to be explaining cumulative frequency graphs, and using these graphs to find estimates for the median and interquartile range of a dataset. GCSE Higher Level questions, giving you a good idea of what you will see when you're sitting the exam. Remember to like and share this video, subscribe to my channel, and leave a comment with any feedback or requests for questions or topics. So now let's begin this question. First off, we're told that this frequency table is showing us the speed of 100 cars. And then for part A, we're told that using this grid, we should plot a cumulative frequency graph using this information that we're given. Since we're being asked to draw a cumulative frequency graph, we should add a cumulative frequency column to this frequency table. It's in this column that we'll get the information which we'll use to plot the graph. So you might be asking, what is cumulative frequency? Cumulative frequency is sometimes known as a running total. So the total by the end of each data set. For example, by the end of this first data set, 0 to 20, we're told that there's a frequency of 6. So the cumulative frequency by the end of this is 6. Within the 20 to 40 values, there's a frequency of 17. But before then, there was a frequency of 6 before 20. So that means before 40 kilometers per hour, there is a frequency of 17 and a frequency of 6. So we add those together to find the cumulative frequency up until that point. Again, up until this point, at the end of this data set, there's 6 plus 17 plus 29 more cars which have been measured, so we add those together. Now we'll continue this to find the cumulative frequencies for the rest of the table. For this group, we add 25 onto the 52 we have so far to get 77. For this next group, we add 20 onto our 77 to get 97. And for the final group, we add 3 onto our 97 to get 100, which gives us the total number of frequency we were told at the start of the question. Now we have the values we need to begin plotting this information onto our cumulative frequency graph. Cumulative frequency graphs are plotted so that the cumulative frequency appears on the y-axis, and what you're measuring, in this case speed, appears on the x-axis. When plotting cumulative frequency graphs, we always use the upper bounds of the inequalities that we're given for our x-axis. So here, we're going to use the values 20, 40, 60, 80, 100, and 120 to plot on our x-axis. And our values on the y-axis, the cumulative frequency, is going to be 6, 23, 52, 77, 97, and 100. So now we can plot these on our graph. We can use a scale to work out how much each little box has in value. What I mean by this is that we can see that there are 5 small boxes from 0 to 10, which means that each small box has a value of 2. Now I've plotted each of these points, as can be seen here, but to turn this into a cumulative frequency graph, we have to join them in a smooth curve. Of course, no graph is perfect, so the values we have here will only give us an estimate of the values we're asked to find, but this will suffice for this question. Now we can move on to part C. Using your graph, find estimates for the median and interquartile range. The key point here is that we have to answer this question using our graph. Let's start with the median. The symbol you'll often find for the median is Q2, and we'll come on to the reason why in just a minute. But first, let's work on finding it out. The median is found using the expression the sum of f plus 1 divided by 2. Don't be put off by this Greek symbol. It's called sigma, and it simply means the sum of. F here refers to the frequency in the table. So all this is essentially saying is that you find the sum of all the frequencies, add 1, then divide by 2 to find the median value. And this gives us 50.5. This value tells us the position of the median value for speed. And it's telling us that it is between the 50th and the 51st position at 50.5. However, because this is a cumulative frequency graph and it isn't going to be completely accurate, we can just use the 50th position, read off the value from there from our graph, and we'll be given the speed. To do this, we go to the 50th position in our cumulative frequency on this graph, on the y-axis, which is here, and we draw a line across to meet our curve. Next, we draw a line from where this line across meets this point on the curve, and we draw it down to the x-axis. Now we must read off this value, which we can see is between 58 and 60, so it's approximately 59 kilometers per hour. And that gives us the value for the median. Again, this won't be exact because each graph is drawn differently, so the mark scheme will give you a bit of leeway with this, between around 1 or 2. So any answer 1 or 2 above or below this will suffice. Next, we're asked to work out the interquartile range. The interquartile range is the difference between the quartiles of a data set. The quartiles are the data values when you divide a data set into 4 equal groups. So we would have Q1, Q2, Q3, and of course Q4, which is the final value. Dividing a data set into quartiles is useful because it shows you the most increase and decrease at different stages. The reason why the symbol of the median is Q2 is because the median is the middle value of a data set, which is of course the second quarter, the half, or the median. However, the interquartile range asks us to find the difference between this lower quartile and upper quartile. You might see these written sometimes as LQ and UQ to indicate that they're the lower and upper quartiles. So to find the interquartile range, first we have to work out the values at each of these quartiles. To find the value at the lower quartile, we multiply the sum of all the frequencies times 1/4. This gives us here 100 is the sum of all the frequencies times 1/4 equaling 25. For the upper quartile, we have to multiply the sum of all the frequencies by 3/4 because it's the third quartile of the 4 divided into, which gives us 100 times 3/4, which is 75. Keep in mind, these aren't the values for the quartiles, these are the positions in the data set which they're going to be at. And we can find the actual values in kilometers per hour by reading these off from the y-axis of the cumulative frequency like we did before. Here we've drawn a line across from 25, which is the position of the lower quartile, and drawn a line down to get our value in kilometers per hour, which is 42. Next, for the upper quartile, we drew a line across from 75, drew a line down to see which value that pointed towards, and we got 78. Now we can write these down as upper quartile and lower quartile values. Now to find the interquartile range, we have to subtract these values to find the difference between them. Leaving us with 36 kilometers per hour. The final part of this question asks us to find an estimate for the number of cars traveling over 90 kilometers per hour. This follows a similar technique to what we did for the previous question, except the other way around. Here we move to the 90 kilometers per hour mark on our x-axis, draw a line up to meet our frequency curve, then draw another line across to the cumulative frequency to find the value at that point. This tells us that by 90 kilometers per hour, there have been 90 cars recorded. We want to find out the number of cars traveling above 90 kilometers per hour, which means that we want to find out the number of cars recorded after this point. So we subtract 90 from the total number of cars, which is 100, leaving us with 10 as our final answer. And this completes this question. The second question starts with a cumulative frequency graph already drawn on for us, and it asks us that from there we must find the median weight and the interquartile range. In this question, we're not explicitly told what the sum of all the frequencies were, like in the frequency table previously, but we can see here that the curve goes up to a value of 60, meaning that the total frequency is 60. So to find the median, again, we find the sum of the frequencies plus 1 divided by 2, which gives us 61 over 2, so 30.5. Again, this is between the 30th and the 31st values, and GCSE stage, we can just go with the 30th value and read off from the graph to find the median. Reading off the curve, we can see that the value at the 30th position is 128 grams. Therefore, the answer to the median weight is that it's 128 grams. Now to find the interquartile range, again we must find the first quartile and the second quartile, which is the sum of all the frequencies divided by 4, which here is 15, or 3/4 times the sum of all the frequencies, which here is 45. So now we read off these two positions. find the values and subtract them to find the interquartile range. At the 15th and 45th values, we can see that the weight is 122 grams and 133 grams. So the lower quartile is 122 grams, the upper quartile is 133 grams, as read from the graphs. We must subtract these to find the interquartile range of 11 grams. Thank you so much for watching this video. Remember to like, share, and subscribe, and leave a comment with anything you'd like to see in the future.